Hello and welcome to another session of Other Two Cents. In this episode, we're discussing the pros and cons of solar thermal power. And my guests today to discuss it with me are Nana Kwame Asumeni and George Nati. Solar thermal because in places like Africa and the Caribbean, developing countries, etc., when you bring solar thermal power to a local level, it is actually something that is attainable. With the existing technologies we have, you can indeed implement at a very micro level a solar thermal plant almost on a residential basis, i.e. house-to-house basis, and it makes it viable as compared to the level of technology and the skills you need to, for example, develop solar panels. If you like what we're doing on this channel, please like our video, leave a comment, and if you haven't already, please consider subscribing. You basically reflect the energy of the sun to a point. That point then is focused on some sort of a heat receptor or receiver. That heat source is then used to basically, heat up some sort of a medium, which is then used to, in turn, heat up water into steam, but at very high pressure to drive a turbine, which then drives a generator, which then generates the electric power you need. In places like Africa, we simply haven't considered this. So the schematic you're seeing here is just a very basic principle of how the solar thermal power works. Now, the bit that I really want to focus on is at this level. Now, this is where it gets interesting, as I said before. For a parabolic dish of this size, you could generate anywhere between 12.5 to 25 kilowatts of continuous power just after sunrise to just before sunset. And that's incredible. 25 kilowatts will typically power, let's say, 5 homes, at any one time. So with every one of these dishes, up to 5 different households could have enough power to power their systems pretty much the whole day. Not everybody is going to be ironing at the same time, right? Not everybody is going to be running, high power consumption machinery like blenders or vacuum cleaners at the same time. So depending on how you guys coordinate or how people coordinate, you could very easily power even more than 5 households throughout the day. The slide you're seeing provides a schematic of the Stirling engine, which is on the left-hand side, a typical rig in terms of how the parabolic mirrors and the Stirling engine will be mounted, and at the bottom right-hand corner, the workings of a steam engine. So depending on how technologically advanced, let's say you are, you could either try and build a Stirling type engine or use a slightly more rudimentary steam engine. A solar sensor that tracks the sun across the day, so the parabolic dish will orientate itself to optimize the amount of energy it's getting from the sun. And throughout the day, from sunrise to sunset, it captures all the energy it needs. I think anecdotally, I've seen anything up to about 60% efficiency. And as you saw on the previous slide, that equates, depending on the size of the dish, of course, anywhere between 12.5 to 25 kilowatts, which is immense. You can see the adoption of solar thermal power around the world. Now, there are bits of it in West Africa, but if you look at the whole of the African continent, yes, there are bits in South Africa as well, but the rest of it is pretty much sparse. So it goes to show that given how much sunlight we get in the tropics and across Africa, this definitely, and especially based on the level of technology required, is something that Africans definitely need to start considering. Because we could, rather than spending a whole lot of money on solar panels, we could develop things like this, create jobs, enlighten people on the fact that you could have one of these dishes in your, if you've got a satellite dish in your house to watch TV, you can effectively have an equivalent of that to provide power. It is literally that simple. The fact that the engines are electromechanical engines and are simple enough will create jobs for the electricians and the mechanics and even DIY self-enthusiasts who want to maintain their own systems. This will create a lot of jobs. I don't frankly know why African countries are not going into this in a big way. So I'll come to you, George, and indeed Nana Kwame. What are your thoughts on this?
I believe between hydroelectric power, solar, that is the PV, and this solar thermal, I believe this will be the cheapest and cleanest, because we are looking at also reducing that negative impact on climate change. So I believe Africans must embrace this technology and then go for it. It will give us appropriate, clean, and affordable energy.
If you understand how an internal combustion engine works, building a Stirling engine or a steam engine is not really that far off. Nana Kwame, what are your thoughts on this?
Myself, as an electrical engineer in the renewable energy space, is something very close to my heart. 3 weeks ago, I was on the site, a CSP plant, which is a concentrated solar power plant, which you just described. And it's amazing. I mean, I've seen it from the air when we're about to land. I was there, I took pictures. And this is something that resonates with South Africa. We've got this renewable energy program running, where there is a host of renewable energy technologies that has been basically considered over the next 10 years. CSP is one, solar, PV, renewables, wind, and a host of others. So I believe that with Africa being in a very advantageous position of having most of these renewable energy resources, it's high time that we invest in gaining knowledge in these technologies and taking advantage of a clean renewable energy to power our economies. So I think it's just about time Africa surge in this direction.
This topic is quite interesting and it's very insightful as well. In Africa, we have the way of doing our things. We always put impediments in other people's ways. Now, if Africa wants to go into this, adapt this technology and use it for our economic development and growth, a few things must be addressed. I think we should be addressing the issue of technical skills. If we do not address the issue of technical skills, we will not be able to adopt this technology effectively. Again, our training, the low quality of our training in our universities must be addressed. We do not want to, or I don't know exactly what happens, but we should embrace the teaching and learning that goes on in the developed countries. We need to address that issue as well. And regulations is also another issue. There must be national regulations. We need to change certain things. We need to prioritize certain things and make sure that financing is also considered. It's very important because this needs a lot of money upfront. The cash upfront for this will need some money, be it small or big. Yes, it will need some money. So financing must also come in at a point in time to enable people, embrace it properly. Then education. We need to educate our people to embrace this thing. I keep using embrace. Yes, we need to embrace it properly because this is going to be a game changer for Africa. Once we adopt it, we will have improvement in healthcare, in education, in all areas of our economic development. So we need to make sure that we do these things and do it well. It's a very good technology, and I like it. It looks good.
Yeah, no, definitely. It's the way to go. but Africa has got peculiar issues. I mean, there's no doubt that energy is a fundamental driver for economic development, and the reason why Africa needs to invest in such technologies, clean energy, cheap, hopefully affordable energy to stimulate economic growth.
For anybody watching or listening, if anybody's ever wanted to get into renewable energy, this at a local level should be one of the candidates to pursue.